Good morning, everybody, and welcome back after, I think everybody would agree, a fabulous evening yesterday. So many thanks to the ASC team for that. I think it was really a beautiful place, excellent food, excellent drinks. Could we have a round of applause, please, for ASC? Thank you. Okay, so we're going to go straight into day two, keep going with the velocity that we had yesterday as well and the series of big themes. We're going to start with a flash talk on disruptive technologies, which is coming from Oliver Reinhardt from Volocopter. Thank you very much.
So, good morning, everybody. Hope you enjoyed the evening the same way as I did yesterday. It was really a fabulous evening, a fabulous event location there. So, really enjoyed it. And now let's get ready to some serious business again. My team had prepared some notes for me to speak from today, but after hearing the discussions yesterday and all the different good inputs, I took it, scrapped it, and scribbled something new down. So, let's see how I can reflect a bit of what we heard yesterday with what we are really experiencing, what we are seeing, being at the forefront of doing new disruptive technologies for a new mode of transportation, as the title of this flash talk is nicely worded. So, quick recap, who are we, Volocopter? Volocopter, we are the ones that are doing the eVTOL aircraft with these many 18 rotors on the top. How did this all start? There were three fascinated technologists, not to say crazy guys, because they are not crazy, but it was a crazy idea at that time. They thought, okay, these toy drones, they work nicely and fly so nicely stable. Why can't we make them work with a human sitting on board of it? And they said, okay, let's do it. They did it in 2011. Most of you probably remember this famous picture of the flying yoga ball with a person with a motorcycle helmet on top, sitting on top of it, controlling himself with a remote control. Yes, maybe that was a little bit crazy, but now it's serious business. And so it was a small step for them. It was a big step for eVTOL aircrafts flying. And it was the entry point into first sending big apologies to our German LBA for doing all of this without any permission to do so. If they would not have done it, I would not be here today. We would not be talking about so much about advanced air mobility, innovative air mobility, however we talk it around the world today, probably. Since then, we've built the first real, like an aircraft-looking vehicle, became airborne in 2013, still remote controlled. Since 2016, we are flying with pilots on board, and we've collected now more than 2,000 test flights, a lot of them also done in public to build public acceptance for this new mode of transport and this new mode of vehicles that comes into the game here. Today, we are in the hot phase of type certifying the vehicle with EASA as being our leading authority here very clearly, and it's actually the 5th generation of vehicle that is now fit for type certification. So it was not the first shot that worked out. We really had to go through these iterations. We started in 2011, and we are looking at type certifying the aircraft in the upcoming year to be ready to fly in Paris late summer next year. So that means it's some 13 years that we were taking since then. What's the time for innovation that we are needing? If I remember back, I'm also in the business now since quite a while, 28 years as I counted yesterday. And actually the very first project I did after I finished university was building an all-electric aircraft. That was 95, 96 with the University of Stuttgart, and we had exactly 1 year available to do it. Everybody told they are not able to do this, but we did it. We were flying the aircraft. I was myself test flying the aircraft then also afterwards. And it was not just electric, it was also solar powered, pilot on board, and it works. From there to the first electric aircraft that got type certified through EASA, that was 2020, the Pipistrel. So that was 25 years, a quarter of a century more than half of the working lifetime of an aviation professional. Is that quick enough? Is our 13 years quick enough? We'll see. Our target is to make a simple product. So what we have decided is to not do any mechanics in our aircraft. We are not tilting rotors, we are not tilting wings. We are not transitioning from one flight mode to another. We are purely operating in this vertical lift mode, even in our slow cruise flights that we are doing. We have a pilot on board. We decided to stay day VFR to start with. We've decided to charge our batteries outside of the aircraft. That all was done really to make the product simple. It's still disruptive, it's still innovation, but to keep it simple. Is this simple? Not really. I mean, we heard yesterday from Alain the link to the ConOps, and exactly there was a point where we started to understand that it's not really simple. When we did dive into these elements, to operate such a vehicle later on and to understand what the safety implications are, we found the ops regulations are significantly affected, the pilot license is affected, reserve energies is one of the famous debates we're having, maintenance is affected, we have complete new systems on board. Infrastructure on the ground, vertiports, charging infrastructure, we heard about this yesterday in the talks. That's all interesting elements, firefighting. It's a complete different level of fire threat that we are introducing with this high power lithium-ion batteries on boards rather than having this simple burning liquid fuels that we all know for many years. It has strong implications on this, diversion sites. Simple thing I mentioned before, we are swapping the batteries. Yes, to swap the batteries, we need a Part 145 that is signing a Form 1 for the charged batteries. Who is signing a Form 1 for refueling a regular aircraft? I mean, there is a number of implications. So, is it simple? It sounds like, but it is not. And keep that in mind when really starting into these new type of projects, also some of them that we heard yesterday. So we heard yesterday that we need to start small but grow fast to then have an impact. When introducing the performance-based CS23, when we did this big rewrite, innovation was also clearly in mind. And there was a safety continuum in the back of all of our minds. I was part of the rulemaking task groups at this time as well, that we can really start to learn and gain experience from these simple elements, learn from it, get data, as we heard yesterday, and then step by step grow them into the bigger projects. EASA took the same approach of this performance-based regulation as we have in CS23, also for the eVTOLs. And that is a brilliant step. Thank you very much for this. I think that's the only way how we really can make this happen. But there is one little detail, and I was just speaking with Joachim also briefly before about this. To do what we are doing with all these implementations, it doesn't come out of nothing. I mean, there are public data available of the colleagues that have gone public as well already. The companies doing this, they have collected multiple hundreds of millions of euros or US dollar in order to be able to do this. We have companies, we have peers that have collected more, and they were required to collect more than $1 billion US dollars in investment to make this happen. Selling such aircraft just to private GA owners, as we had in mind, talking 23, level 1, where you can simply test your innovation, that doesn't pay off. Nobody gives you money for that. So we have to go commercially all in. We have to jump the first step, directly the highest step, to come to a commercially viable product that has a chance at all to pay back for all those investments. And that's a bit of difference compared to what we had in mind when we were talking 23 on this, back when we were doing the renovation of the regulations there. We heard yesterday also there is a symbiotic link between safety and innovation, and I really liked what you were pitching there. That really brought it nicely to the point. And yes, the one doesn't go without the other. It is strongly connected together. In the safety continuum, you can build this and you can put commensurate levels to it. Now, keeping in mind what I just said of where we are commercially forced to go into, we end up rapidly at the point that we need to do it from the start at the high level of safety. There is just not much debate, not much room for debate in order to do it this way. And that's a challenge. I mean, these urban air vehicles will be mostly operated by commercial airlines in the end. A passenger who enters an aircraft that is operated by a commercial airline has a clear expectation on safety. He doesn't want to think about it. He accepts it as given, as there, just the reputation that we have built over decades in commercial airlines operations as of today. So yes, we have debates around the globe on how do we ensure this level of safety with innovative air mobility, urban air mobility, however we call it in there. So the customers that want to fly from Singapore to Sumatra or from Seville to Madrid or from the city here to connect to the airport of Seville, or they want to fly from San Francisco to Fisherman's Wharf with an eVTOL aircraft. They want to have the clear understanding they are entering an aircraft at the same level of safety. That is, in the end, for them, operated at the same level of safety. There are different ways of achieving it, but somehow we need to come together to a common understanding that we give the customers what they are expecting. Let me have some dedicated look at some of the technologies we are looking at. One of the things, and I'm looking at Guillaume, where we had also many of the discussions in this, what we have, no mechanics, but we have a flying computer. Simple as that. That machine is full of computers. And none of these computers is an ETSO equipment that we get off the shelf. There is a minimal part of those components that we have on board. Most of it is fresh, is new. What does it mean? We have dozens of SOIs. We have dozens of system reviews to go through. And that's a challenge. That's a challenge for us as a company to ensure we have it. That's a challenge for EASA and for all the authorities to ensure. I mean, those capacities, those resources, those people that know how to do this, they are scarce on the market, and we all have the same challenge to get it together. Nevertheless, we want to make it work. Take it one step further. Once this thing is certified, what do you expect from your computer at home? What do you expect from your smartphone? It's continuously developing. Next technology level gets incorporated. Next software levels get upgraded. Next features come in to get more and more safety into it. How can we keep the pace after the first certification, which is a power act, then to really continue to develop it? And it doesn't end with us. I mean, just 3 weeks ago, we had an exchange with your experts, and you see it coming up more and more on the legacy aviation as well, these customized units. That's really something we need to address, and how can we do this? Yeah, I see my time running, so let me jump one topic. Yesterday, we spoke of artificial intelligence and machine learning. That's a very valid discussion, and also we see we will have strong benefits out of this in the future. What we did not really touch so much upon yesterday was cloud-based infrastructure, cloud-based computing, using cloud-based systems. There are a lot of good reasons for doing this, and just out of my experience, out of our experience, looking at our company. When I came to the company, we had in the basement of our building the shelves of the servers sitting. We were hosting all our services ourselves. In the meantime, that's no more the case. We are working cloud-based. So all the engineering software runs cloud-based. Our office runs cloud-based. Everything we are doing is cloud-based. Why did we do this? Because it's more stable, it's more safe, it's more secure. Securing the backups, it's much easier. Being protected against hackers is much easier to do it when you have professionals there whose full day business is to secure these type of data and make it with them and have them do it. So now we are in the process of getting our AOC together. One of the questions that came during the audit was, okay, how do you manage your data? Yes, here, so and so, it's all safe, it's all secured, we have all the contracts in place, we can show you, we have done it, we have played it back. Okay, that sounds nice and good, but please show me now where is the hard drive that we can pull if we have an accident and we need to do an investigation. The hard drives are gone. So how are we dealing with this? That's just a simple example out of real life we're having today. And yeah, that's something we need to address. It continues then also towards traffic management. I mean, the visions of all these eVTOL players is to have thousands of aircrafts afterwards in the air around the globe flying. We need to manage them somehow. How can we manage them? Manually? Likely not. Okay, let me flip the sustainability element because that would probably be a flash talk on its own. There we also have, of course, some elements to go. Performance-based regulations, very clearly we mentioned before and we discussed it yesterday. And looking back also at my experience, I've been in quite a number of rulemaking task groups with the authorities. I've been chairman on the ASTM F37 since somewhere in 29. Since 27, I'm doing industry standards. Today, I'm a co-chair of Working Group 112 at EuroKE, which is another good example for this partnership approach with EASA. My co-chair is Lionel Tausig from EASA. So that's a very good and strong partnership in working, developing these standards, and a perfect example of doing this. So we had yesterday, we heard a bit the pitch on, we need to invest into these standards. So if you ask me as a co-chair of Working Group 112, am I happy? No, I'm not. I'm by far not happy with the performance that we have on the industry standards group right now. But where does this come from? And I try to reflect this. When I was F-37 light sport aircraft at that time, we were talking about aircrafts that existed, were mostly flying as ultralights. At that time, FAA said, we do a deregulated space, you can develop some industry standards, and then we will accept these. That was a nice start there. But we are talking about something that exists, everybody knows, and we could openly speak about this, and we could rapidly come to standards. F-44 started with the CS-23. And there I was in the first moment with the 37 experience a bit shocked how slow it was in the beginning. It really took 1-2 years for those legacy aviation players to come in to understand there is a sense to open up your books, to share your mishaps and to share your experience in order to come to a nice standard. But we took up speed and then it worked out. So now, Working Group 112, eVTOL aircraft. None of these aircraft is out flying type certified. You cannot see them just going to a trade show and sit in them, watch them, see them. Nearly none of them are flying publicly. There is a lot trade secret still behind this element. So what we are seeing is those people that are sitting in the standards, they are very much tempted to keep their books closed still and are limited in being able to share their experience. Does that help us? No, not at all. Next thing is we have in this project, that's typical, many enthusiastic young engineers. They are not used to that process. They don't have the understanding yet. They don't have the feeling yet of what can be done, should be done, and should not be done. And last but not least, naturally, we have the authority sitting in. And it's the nature of the beast. The authority has a strong word in these committees because in the end, you can decide on every standard you want. When the authority doesn't accept it as an AMC, it's useless effort. So yes, of course, there is this, let me call it tension in it, which is not bad per se, but we need to deal with this. And last but not least, we have competing systems. And that's not a good thing. With everything that I mentioned before, having the difficulty to get the people in, also remember what we are getting the money for is to get the product certified and out of the door. We are not getting the money to sit on committee meetings. It's really difficult to make it visible to those investors to say, hey, that's part of the game. It's not just EASA leaning back and saying, okay, you do the work now for us on the regulatory side. That's not what it is. But to explain this to investors and to the different bosses of the companies is really a challenge. So maybe that gives us some key points and some areas to think about how we can get out of this. We need to get out of this because that's really the right way to go. So, let me start to summarize. Very clearly, I would not be here today, Volocopter would not be here, our peers would not be here today if we would not have this significant openness for the partnership in innovation with the European Commission, with the EASA, with the national aviation authorities of the member states here. So that's a very clear thank you from my side on that end. What we have started here is really a huge and a big step. If you would have asked me some 10 years ago, is that possible? I'm with Volocopter now since 6 years, so late 2017 was our first approach to EASA saying, here, we have an application for a type certificate, let's do something out of it. If you would have asked me 10 years ago, I could not have imagined this to happen. So very much thank you for that and everybody involved in that. Let's continue on that path. As always, devil is in the details. We have systems that work for incremental improvements. For really paradigm change, when we do the disruptive innovation. We've done a step in the right direction, but I think we need to go significantly further ahead to make this happen. What we are doing, the real true innovation that kicks in, normally doesn't come from incremental change. It comes from trying something completely new, and we need to be able to do this in a sustainable way. We are used to incremental change in the past. Incremental change did allow us to learn in different ways, to test in that direction, to test in that direction. We see different approaches on the different countries, continents to approach into this. Once we have learned, we have the data, we start to bring the pieces together to harmonize. That's one thing that we clearly see here today. In such a disruptive technology we are bringing in, which is affecting all of the regulatory regimes in the end, that doesn't really work. The effort to adopt the regulatory system is so huge that we cannot afford trying here, trying there, and then bringing it together. And after all, our aviation industry is a global industry. So that is my last point then for my flash talk today. Also something where we need to talk about, continue to work on. How do we get our act together then also on a global way, that in the end we have commensurate systems that work together. They don't need to be perfectly harmonized. No way, there are local differences. That's fine, but they need to be reasonably synchronized, that what I mentioned before, our customers can expect the same level of safety wherever in the world they go to. We do the same thing when we fly our commercial airliners. We are securing the same elements. Let's do this in the same way also for these novel and disruptive technologies. And what we are doing today with urban air mobility, innovative air mobility, is a perfect learning case for this. We are the guinea pigs. That's fine. I'm used to this. I enjoy being this. Let's take the lessons learned from there and then make jointly the next steps. Thank you very much for your attention.